Question number 6 asks, how do scaffold proteins prevent crosstalk between distinct signaling pathways? Well, the way they do this is by basically concentrating all the different kinases and the kinase targets, or you could also call them substrates, in a relatively confined volume. So basically, scaffold proteins will bind numerous kinases and the proteins that the kinases are acting upon all as a part of a very large supercomplex. All right, so because of this, if we have, one scaffold protein here with, kinase A, its target B, and then B's target, let's say B is another kinase, its target C, it's very easy for, A to phosphorylate B and B to phosphorylate C. But, protein D, that maybe, let's say D is a kinase here and a different signaling cascade. And let's just say, A is technically, able to phosphorylate D and turn it on. Well, if D isn't part of that scaffold complex, A is going to preferentially phosphorylate other proteins that are next to it, right, rather than the ones that are not. D also might be part of a different um, complex bound to a separate scaffold protein. So you could have, kinases D, E, and F bound to their own scaffold protein. And because of this, D will preferentially phosphorylate E, and which will preferentially phosphorylate F. And there will be the amount of crosstalk between these two different complexes will be minimized due to aggregation of the kinases and their substrate proteins. That's it for number 6.